Ants invented the algorithms that power our modern technology. Inspired minds, nature sparks technology. What if I told you that some of the most advanced technologies powering our modern world, from navigation apps to global delivery networks and even parts of artificial intelligence, were not invented by human beings at all? What if the blueprint came from one of the smallest, most overlooked beings on Earth? Ants. Yes, tiny, silent, easily ignored ants created the fundamental logic behind some of the most powerful algorithms we use today. Welcome to Inspired Minds, where we uncover how nature itself shapes the innovations that define our future. Today, we explore the unbelievable intelligence hidden inside ant colonies and how these tiny creatures solved problems millions of years before human civilization even existed. At first glance, an ant seems simple, almost insignificant. But when you zoom out and look at the entire colony, something incredible appears. A colony doesn't act like a group of individuals, it behaves like one unified, decentralized superorganism. There is no leader, no command center, no central intelligence giving orders, and yet together they complete tasks that would challenge human engineers and computer scientists. Ants can locate the fastest route to food, reroute around blockages, coordinate massive groups efficiently, distribute resources flawlessly, and adapt almost instantly to sudden changes in their environment, all without language, without planning, and without any top-down structure. Their intelligence comes from simple rules followed consistently by each ant, combining to create complex and powerful collective behavior. Scientists call this swarm intelligence, and it is one of the most compelling examples of natural computation on the planet. In the 1990s, something remarkable happened. A computer scientist named Marco Dorigo began studying how ant colonies search for food and navigate terrain. The deeper he studied, the more he realized he wasn't just observing insects. He was witnessing a natural optimization process that resembled advanced computational problem-solving. Ants, without knowing it, were performing complex mathematical tasks that human beings had been struggling to compute for decades. One of the biggest challenges in computer science is finding the shortest route between multiple points. It's known as the traveling salesman problem, and it forms the foundation of many modern systems: delivery route planning, network design, mapping, and logistics. Humans built sophisticated algorithms and supercomputers to try to solve it efficiently. Ants, they solved it with nothing but pheromones. Hear how their natural algorithm works. When ants leave the nest searching for food, each ant wanders randomly. As it walks, it leaves a thin trail of pheromones. When ants return with food, they reinforce the same path with more pheromones. Shorter paths get reinforced faster because ants return more quickly. Longer paths evaporate or weaken because fewer ants travel them. Over time, the colony naturally highlights the fastest, most efficient route, not through planning but through repetition, feedback, and chemical signals. This simple, elegant system became the foundation for what computer scientists now call the Ant Colony Optimization Algorithm, or ACO. Today, this algorithm is used in some of the most important technologies around us. When you open Google Maps and ask for the fastest route, you're using a modified version of ant logic. When a delivery company like Amazon calculates the most efficient path for dozens of packages, it relies on this ant-inspired method. When internet networks route data across the world, they use decentralized, pheromone-like reinforcement strategies that mirror ant behavior. But it doesn't stop there. Autonomous drones use swarm logic to navigate without colliding. Robot teams exploring disaster zones rely on distributed decision-making modeled after ants. Modern AI uses ant-like strategies to evaluate thousands of possible solutions at once and select the most efficient. Even large-scale traffic systems use ant-inspired models to predict congestion and reroute vehicles, just as ants reroute around obstacles. It's astonishing to think about this. Millions of years before human beings invented algorithms, nature had already perfected them inside ant colonies. And scientists realized that ants weren't just similar to algorithms, ants were algorithms. Living, evolving, adapting computational systems that outperformed many human designs. What makes ant intelligence so powerful is that it is decentralized. There is no main brain. Each ant follows simple rules, but the group produces complex intelligence. This means the system has no single point of failure. If a queen dies, the colony continues. If an obstacle appears, the route adjusts automatically. There is no panic, no breakdown, just fluid adaptation. Human systems often collapse when a central node fails. Nature's system simply recalibrates. Ant intelligence is also adaptive. When a route becomes blocked, ants don't freeze, they don't debate. They immediately begin exploring alternatives until a new optimal path emerges. And the moment it does, pheromone reinforcement marks it as the new main route. This is the same behavior your navigation app uses when it instantly reroutes you around traffic or accidents. The efficiency of ant colonies is something engineers admire deeply. Every step serves a purpose. Every decision pushes toward optimization. Ant logic wastes almost nothing energy, time, or resources. It's nature's version of maximum output with minimum cost, and the system scales perfectly. 10 ants or 10 million ants, the colony's behavior remains consistent, stable, and effective. This is why researchers believe that ants might hold the key to the next generation of artificial intelligence. While humans have always built centralized systems, massive servers, huge control centers, large neural networks, nature built intelligence through decentralization, through cooperation, through simple rules repeated millions of times. Imagine a future where entire cities run on ant-inspired algorithms, where traffic flows smoothly without bottlenecks, where energy grids self-balance, where robots build structures the same way ants build bridges, where networks repair themselves just as ant colonies adapt instantly to threats. Scientists are already working on self-healing networks inspired by ants, systems that automatically detect and repair digital wounds without human intervention. Researchers are developing swarms of construction robots that can assemble buildings the way ants assemble complex nests. AI developers are exploring decision-making models where intelligence emerges from the cooperation of many simple agents, rather than one monolithic system. All of this began with tiny ants searching for food. Nature often solves problems long before human beings even realize the problems exist. And ants, through millions of years of trial, error, and adaptation, evolved some of the most powerful optimization strategies we know. Strategies that shape the digital and physical systems of our modern world. Ants don't just survive, they innovate. Their collective intelligence is a reminder that solutions to our biggest technological challenges may already exist in the natural world, waiting for us to notice. Their algorithms guide our navigation, support our networks, empower our AI, and inspire new technologies that could shape the future of humanity. If this story changed the way you see nature and technology, then subscribe to Inspired Minds, where every week we explore the hidden intelligence woven into the natural world. Because sometimes, the smartest ideas don't come from human beings, they come from nature itself. Let the ants remind us, innovation doesn't always start in a laboratory, sometimes it starts beneath our feet.